Welcome to another video on your Chapter 10 lecture series. Here we're going to discuss Section 10.7 on factors affecting skeletal muscle tension within the body. So the first term we'll discuss is muscle tone, and this is a resting tension that takes place within your muscle. It's generated through involuntary nervous stimulation of our muscle fibers, and some of our motor units are going to be stimulated randomly at any time. So let's say at one point our motor unit 1 is going to be stimulated, and then we stop stimulation there and pick up stimulation with motor unit 2. So your muscle will constantly have this tension placed within it. And by switching off back and forth like that between the motor units, your muscle is not going to become fatigued, and you're not going to generate enough tension for movement to take place, just for that muscle to be toned. And this tends to decrease during deep sleep. And we're going to discuss the different types of contractions that your muscle can have. So first will be isometric contraction. This is where tension is going to be increased, but it's insufficient to overcome resistance. So you're essentially just holding that resistance in your hand. There's no movement taking place. So I also like to describe this as if you were trying to move a wall and you're pushing that wall with your arms, let's say, but you're not actually changing length of the muscle here. You're just kind of creating tension within your muscle. The other type of contraction we have is isotonic contraction. This is when we have muscle tension that does overcome resistance that results in movement. And the tone is going to stay constant, but we see a change within its length. So we have two subtypes of contractions in isotonic contraction, and that is concentric contraction, which is taking place over here. We see that we are overcoming that resistance, and our muscle is shortening as it contracts. So here our biceps brachii is lifting a load. That's our example of concentric contraction. Now in eccentric contraction down here, our muscle is actually lengthening. So we are moving that resistance and our muscle is going to lengthen. Our biceps brachii here is becoming longer as we are lowering this dumbbell. And here's another figure from your book showing you isometric contraction, where the skeletal muscle here, your biceps, is creating tension within it, but the muscle itself is not shortening or moving as you're holding the baby there. But if you are bringing or holding your baby in your arms and bringing the baby up toward you, that would be concentric contraction because our muscle is going to shorten. And when you bring that baby back down, maybe to lay it in its crib or on the changing table, then the muscle is going to lengthen as you extend your forearm down in eccentric contraction. And here are some graph views of these different types of contractions. Along the y-axis here, we are going to see the length of tension, and on the x-axis we have time. So during an isometric contraction, we can see that muscle tension is increasing as time continues. And within our isotonic contraction, specifically concentric contraction, we see that tension is starting off high, and as that muscle length is decreasing, we will see that tension decrease. And lastly, our isotonic contraction, eccentric contraction, we start with that tension low, and as time goes on, we see that muscle length and tension is going to increase. And just a little clinical view here on isometric contraction and increase in blood pressure. If we were to sustain that isometric contraction, we see an association with increase in blood pressure. This could be a concern for those that have a baseline of high blood pressure, as it could send their blood pressure even higher. And an example of this would be shoveling snow. Our general peripheral constriction from the cold is going to elevate our blood pressure already. So if we relate this back to what we talked about in homeostasis and what happens to our body in a cold environment, you could see here that we have vasoconstriction taking place in our blood vessels. And so when we have isometric contractions taking place while shoveling snow, it tends to increase the pressure even more so. So here are some good tips to take if you do have high blood pressure and are shoveling snow. You want to take breaks. Don't drink alcohol before or after shoveling snow. If you have any signs of a heart attack, stop shoveling and call 911 and push the snow rather than lifting it so that you are not performing that isometric lift, and use good form. If you do need to lift, do so with your legs and not your back. And lastly, take it slow, not snow, and lighten your load. Now let's talk about the length-tension relationship in muscle. The tension a muscle produces is going to be dependent on its length at the time of stimulation. So fiber at rest, like we see over here, this is a figure from your book. This figure is matching this, but I just thought it was a little bit more descriptive. So anyway, when our muscle fiber is at a resting length, we are able to generate maximum contractile force because we are able to have that optimal overlap of our thick and thin filaments. Whereas if our fiber is shortened, let's say it's already partly contracted, then we are going to generate a weaker force. Our filament movement is very limited because we already have that Z disc close to the other Z disc. And then if we have our fiber at an extended length, then it's going to generate a weaker force as well because we have minimal thick and thin myofilament overlap, so that cross-bridge formation is a little bit more difficult to take place. And now for our topic on muscle fatigue. This is going to be when we have a reduced ability to produce muscle tension, just like how we saw in this previous slide on tetany in our previous section, right? We fatigued our muscle out there. And the primary reason we have that fatigue take place is because we have a decrease in glycogen stores due to prolonged exercise. But we have some other possible causes of fatigue. It might even be a combination of these. It could be that we have excitation at our neuromuscular junction, meaning we don't have enough calcium to enter our synaptic knob, which means we would have decreased number of synaptic vesicles, exocytosing and releasing acetylcholine here. We could have an issue with our excitation contraction coupling, meaning that we have an altered ion concentration that is impairing the action potential conduction and following through the sarcolemma to the T-tubule and releasing that calcium from the sarcoplasmic reticulum. Or maybe we have an issue with our cross-bridge cycling where we have excessive inorganic phosphate that is going to slow the release of inorganic phosphate from the myosin head. Or we have less calcium available for troponin that would shift that tropomyosin out of the way.